So now we will be discussing the STP concepts. So it is the module 5 of SRWE course. So I already started reading Ether channel, and I think we have here one packet tracer. So this packet tracer will be included on other playlists. So okay, so first introduction. So what will I learn to do this in this module? So the module title is STP Concepts. And the objective of this module is explain how STP enables redundancy in a layer 2 network. So we will be able to know what is the meaning of redundancy later on. So I have here three topics. So the first one is purpose of STP. So in this topic, we will explain common problems in redundant layer 2 switch network. And the STP operations, we have to explain how STP operates in a simple switch network. Then, the evolution of STP. So, explain how rapid PVST plus operates. So, purpose of STP, so redundancy layer 2 switch networks. So, okay. So, redundancy is an important part of hierarchical design for eliminating single points of failure and preventing disruption of network services to users. So, redundant networks require the additional of physical paths, but logical redundancy must also be part of the design. So, as you can see, we have here the additional of physical paths. Okay, sa STP. I was confused because I already reading this Ether channel. Okay, so spanning tree protocol. So this protocol is a loop prevention network protocol that allows for redundancy. So the redundancy is the addition of multiple paths. So as you can see, we have here path 1. For example, we have here the path 1 and the path 2. So we have here the path from S2 to S1. So we have here two paths. So that it is called the redundancy. So the STP, so it allows redundancy while creating a loop-free layer 2 topology. Okay, we have here example video animation. Okay. So it sends. So broadcast to all ports. So STP blocks the ports, some of the ports to it was blocked because if it is not blocked, so it will repeat the process. So STP is a loop prevention network protocol. So it prevents loops in a network. Okay. So STP recalculation. So the STP compensates for network failure. So for example, we have here failure in this path. So the STP recalculates. So it opens the block paths, as you can see. So the trunk link between these two has failed. So S2 blocks the port for trunk 2. So basically, it's just a recalculation for STP. So whenever a link fails. I have here the issues with redundant switch links. So issues with redundant switch links is a loop. So layer 2 loop can occur. So we have there the layer 2 loops. So Without STP enabled, layer 2 loops can form, causing broadcast multicast and unknown unicast frames to loop endlessly. So as you can see, let's play this animation. So it sends to S2. I think this is a broadcast message. Okay. So this is a scenario wherein we don't have the STP configured. Okay. So the frame will be back on this port, then we'll flood the port again. So the cycle starts again. Okay, so broadcast storm. So it is the abnormal high number of broadcasts overwhelming the network during a specific amount of time. So this animation will surely. We have here the broadcast. Okay, PC1 forwards out the broadcast. So this is the broadcast frame from PC1, and then this is the broadcast frame from PC4. So it also gets caught in the layer 2 loop. Then PC3 also sends a broadcast. So it forms a broadcast storm. So PC2 forwards out broadcast frame but cannot be processed due to high traffic overload on the network. Okay. So this is the broadcast storm. So it is an abnormally high number of broadcasts. Okay. So we have here the spanning tree algorithm. So STP is based on an algorithm invented by Radia Perman. So I have here the explanation of STA, how STA creates a loop-free topology. Okay, so STA scenario topology. So we have here the redundant, so Ethernet LAN twin with the redundant connections between multiple switches. So for the second one is, so we need to select the root bridge. Okay. Next is we need to block the redundant ports. So we only have one path to root bridge. So as you can see, all these double paths here are blocked with one port. For example, we have here the S4. So the link toward S5 is blocked. So we have here the path for S4 to S1 through S2, but the path from S4 to S1 through S5 is blocked. So it is the STP is used to prevent the layer 2 loops. So loop-free topology. The link failure causes recalculation. So whenever a link is fails, so we have here the recalculation, as you can see on the last example here. We have here the link from S4 to S5, so it is blocked. So whenever this path fails, so the STP recalculates the topology and opens the block port. So we also have here the video of STP operation. So in this video, it just summarizes all of this topic. Now for the STP, so we have here also the packet tracer. So we will be including this on the packet tracer activities on different playlists. So check your understanding purpose of STP. So which statement best describes STP? So it is a layer 2 loop prevention protocols for Ethernet LAN. So it involves switches. So it is a loop prevention but not on a layer 3. So which STP and the Ethernet LAN, which three types of frames could cause a catastrophic loop in the network. So here the broadcast, multicast, and a non-unicast. So if it's unicast, so it will just forward into the specific host. But when a unicast, so it causes a broadcast. So what device is selected by spanning tree algorithm to which all other switches determine a single least cost path. So it is the root bridge. So now here in the STP operations. So here are the steps to loop free topology. So elect the root bridge, elect the root ports, the designated ports, and elect alternate or blank ports. So this is the showing the during STA and STP functions, switches use BPDU or bridge protocol data units to share information about themselves and their connections. So BPDUs are used to elect the root bridge, root ports, and designated ports and alternate ports. So I think this is the this is the BID. So it is a part of BPDU. So the BID includes the bridge priority, extended system ID, and MAC address. So I think the lower the bridge priority, the lower the bridge BID, so it is the elected as root port. The lowest bit ID is determined by a combination of these three fields. So whenever the bridge priority is the same, has the same value, so extended system ID would be the one to decide, and also the MAC address. So the lower the MAC address value in terms of converted hexadecimal value. Okay. So bridge priority, so it has the default value of 32768. Extended system ID, so it is a decimal value added to the bridge priority value in the bit to identify the VLAN for this BPDU. So the VLAN ID is also included in the information here in the extended system ID. So also the MAC address. So the first one is to elect the root bridge. So the root bridge is selected through the priority here. So as you can see here, we have the S1 as having the lowest priority. Okay. So impact of default BIDs. So because the default BID is 32768, so it is possible for two or more switches to have the same priority. So as shown here, we have here the same priority. So how can we select the root bridge? So it is through the MAC address. Okay. So here the MAC address becomes the deciding factor as to which becomes the root bridge. So as you can see here, we have three MAC addresses here, and the MAC address of S2 has the lowest value, so it is selected as the root bridge. To determine the root path cost, we have here the root path cost. Okay. So the path information known as the internal root path cost is determined by the sum of all individual port costs along the path from the switch to the root bridge. So the root path cost is basically the number of paths from the switch to the root bridge. So elect the root ports. So after the root bridge, we need to select the root port. So every non-root switch will select the root port. So the root port is the port closest to the root bridge in terms of overall cost, best path to the root bridge. So after selecting the after electing the root ports, we also need to elect the designated ports. So it's quite confusing, but I think the root port is the one with the egress, and the designated port is the ingress. So it uh, it accepts frames. Okay, let's see. Every segment between two switches will have one designated port. Okay. Designated port has the best path to receive traffic leading to the root bridge. Root bridge. So as you can see, we have here the designated port, the root port, and designated port. As you can see, we all have all the ports of root bridge will be a designated port. So for example, here we have a frame going to PC4. So the root port is the egress. So the frame comes out with this port, and then the designated port is, so it accepts the frame. So ingress and egress. Egress and ingress. We also have the designated port when there is a root port. It's also, so if one end of a segment is a root port, then the other end is the designated port. So for example, here for the link between S4 and S3, we have here the root port here and the designated port here. So if one is the root port, then the other link is the designated port. Designated port when there is no root port. Okay. I think it will be a black port. So like alternate ports. So if it's a port is not a root port or designated port, then it becomes an alternate port. Okay. Wait. Also, in configuring the root ports, in configuring the best path is, I think the path cost, I think. Then it computes the path 1 and the path 2. So the path 2 cost is larger than the path 1 cost. So path 1 is preferred path. So for example, we have the PC3 sending a message to a PC4. So it goes to S2 and then S1. So imagine, so you will just select the shortest path. So elect a root port from multiple equal cost paths. So if we have a root port, so if we have multiple equal cost paths, so how can we elect a root port? So first one is the lowest sender bid. Second one is lowest sender port priority. So it have the lower port priority, but in this example we have here the same port priority. So we'll just determine on the lowest sender port ID or in the MAC address. So STP timers and port states, we have 3 timers on STP convergence. We have here the hello timer, forward delay timer, and max age timer. So the hello time is the interval between BPDUs. So it is 2 seconds. The default second is 2 seconds. But it can also modify to between 1 and 10 seconds. So we have here the forward delay timer. So the forward delay is the time that is spent in the listening and learning state. So each state is 15 seconds, but can be modified between 4 and 30 seconds. So max age timer. So max age is the maximum length of time that the switch waits before attempting to change the STP topology. So it is the timer before attempting to change the STP topology. So it has a default default time of 20 seconds, but it also can be modified between 6 to 40 seconds. Okay, we have here some port states. So we have here the blocking. So the port is blocked, so it does not participate in frame forwarding. We also have the listening. Okay. So port receives BPD to determine the path to the root. The switch port also transmits its own BPDU frames and informs adjacent switches that the switch port is preparing to participate in the active topology. So you have your listening and learning. So it also begins to populate the MAC address table. So this is the state. So forwarding, forwards frames. So it has an active part of the topology and disabled, so it does not participate, and Spanish and does not forward frames. Okay. Then operational. So for the operational details of each port state, so we have here the table that summarizes the operational details of each port state. So for the blocking, so it just receives the frame, so it does not update the MAC address table, and also does not forward data frames. So we have the listening, receive and send, does not update and does not forward data frames. So learning, receive and send. So listening to forwarding, it receives and send. Then for learning and forwarding, it also updates table. So the only difference is that the forwarding forwards frame. So the disabled, so none sent or received, and does not update MAC address table and also does not forward data frames. Okay. So per VLAN spanning tree, so it is a version of STP. So there is a root bridge elected for each spanning tree instance. So it is STP on multiple VLANs. So it makes it possible to have different root bridges for different sets of VLANs. Okay, check your understanding. So by default, what will determine which switch is the root bridge? Bridge ID. Mamaya po. So the root bridge will be the switch with the lowest bridge ID. So the port closest to the root bridge in terms of least overall cost to the root bridge is the root port. So the port on the segment with two switches that has the lowest path cost to the root bridge is, so it is a designated port. So which of the following ports will forward Ethernet frames? So we have here the designated port and root port. So the sum of individual port costs along the path from the switch to the root bridges is known as the root path cost. So how often does a switch send a BPDU? So I think it's every 20 seconds. Here, the MAC address of the switch. Okay, every 2 seconds. So you got the correct answers. So for the last topic is the evolution of STP. So we also have different versions of STP. So up to now we have used this term STP and acronym STP, which can be misleading. So many professionals generally use this to refer to various implementations of STP. So I have the RSTP, MSTP. We also have different standards for spanning tree. So this is the STPs and its descriptions. So here the STP, so it is the original STP that provides loop-free topology in a network with redundant links. Also have the PBST, so it is STP on VLAN. So we have here the 802.1D2004, so it is an updated version of STP standard. Then the RSTP, so it provides faster convergence than STP, so hence the called rapid spanning tree protocol. We also have the rapid PVST plus, so it's the same as the RSTP, but it supports port fast, BPTU guard, filter, root guard, and loop guard. Then also have the MSTP and MST, which is the multiple spanning tree protocol and multiple spanning tree. So we have here the RSTP port states and port rows. So in this example, we are comparing STP and RSTP. So as you can see on the RSTP, the disabled blocking and listening of STP is discarding in RSTP, but learning and forwarding is much more the same. So STP and RSTP port rows, so root port and designated port is the same on STP and RSTP. So the only difference is the block port of STP. So we differentiate the block port to backup port and alternate port on the RSTP. So RSTP alternate and backup ports. So the main difference is the alternate port has an alternate path to the root bridge. So as you can see on the diagram, so the backup port is a backup to a shared medium such as sub. So this backup port is considered as the legacy devices. So it is less common nowadays. Port fast and BPTU guard. So the port fast. So port fast is used to, where is it? So it is port fast is used to immediately transition from blocking to forwarding state. So it bypassing the listening and learning states. So it is used mostly for DHCP clients. So listening and learning states have a 30-second delay. So we need to configure it with port fast to immediately transition or bypass the listening and learning states. So we have the alternatives to STP. So I think in this diagram we Ethernet LANs went from few interconnected switches connected to a single router, so to a sophisticated hierarchical network design including access, distribution, and core layer switches, so as shown in the figure. So nowadays we are using multi-layer switch. Okay, so the switches here, the layer 2 switches, are now changed to layer 3 switches. So the PC here, or the personal desktop, now are connected to multi-layer switches. Check your understanding. So version of STP. So which 3 STP port states are merged into the RSTP discarding port state? Okay, we have listening, blocking, and disabled. Okay. So which protocol was designed to bring faster convergence to STP? So we have the rapid STP. And the last is, which technology solves the problem of a device being unable to get an IP address from the STP due to STP forwarding delay time? So we have the port fast. Now for the last part is the module practice and quiz. So in this module we have learned the purpose of STP, the STP operations, the evolution of STP, and then for the last part we will be answering the module quiz for STP concepts. So number 1 is, what additional information is contained in 12-bit extended system ID of a BPDU? So we have discussed earlier that the VLAN ID is contained on the extended system ID of bridge protocol data unit. So number 2 is, during the implementation of STP, all switches are rebooted by the network administrator. So what is the first step of spanning tree election process? So all the switches send out BPDs advertising themselves as the root bridge. So which STP port role is adopted by a switch port if there is no other port with a lower cost to the root bridge? If there is no other port role, root port. So which two concepts relate to a switch port that is intended to have only end devices attached, intended never to be used to connect to another switch? So here the port fast and the edge port. So which two statements describe a switch port that is configured with port fast? So as we mentioned earlier, so it immediately transitions from blocking to forwarding state, and then so the switch port should never receive BPDUs. So which port state will switch ports immediately transition to when configured for port fast? So when configuring with port fast, so the transition is from immediately transition to. So transition to means forwarding. Oops, not forwarding. 7 left. So after the election of root bridge has been completed, how will switches find the best paths to the root bridge? Some of our protocols. This is the answer. So 8 is, what value determines the root bridge when all switches connected by trunk links have default STP configurations? The answer would be the MAC address. So which RSTP ports are connected to end devices? So here the edge ports. So which 3 port states are used by RPVST? The discarding, turning, and forwarding. So when PVST is running over switch network, which port state can participate in BPDU? Frame forwarding based on BPDUs received but does not forward data frames. So it can receive but not forward data frames. So it would be listening. So last 2 questions. So an administrator is troubleshooting a switch and wants to verify if it is a root bridge. So what command can be used to do this? So it should be show spanning tree. So for the last question is, what is an accurate description of redundancy? So redundancy is the additional paths check. So we all got correct answers. Okay. So the next module is the Ether channels. So it's also quite interesting reading this. So I think in this Ether channel we will also configuring Ether channel with packet tracers. So the packet tracers would be included on other playlists.